So here there is an question on a carriage spring we call as a laminated spring or leaf spring. Okay, so first I will explain what is a leaf spring here. Later we will go to solve this problem. So where leaf spring, it consists of the number of plates of metal plates having a different width and their length. So these plates, it will support the main or master leaf. So in general this will be used in the automobile to absorb the shocks. Okay, for example, here this is the main plate and here the number of plates, it will be attached to the main plate and it will be clamped together and the load will be applied this direction. So for this problem you need to design or you need to find the different values, like you have to calculate the central deflection using all these input parameters. So a leaf spring or carriage spring of 750 millimeter is the length. Okay, so this is the length of the spring given as 750 millimeter from here to here. Is built up of plates. Okay, so each plate, for example, each plate if you take like this, there 70 mm is the wide. This is the 70 mm is the wide, means this one as 70 mm wide, and having a thick, the plate thickness is 8 mm is the thickness. So now question is, how many plates are necessary to support a central load of 100 kilonewton? So how many plates are required? Okay, so how many plates are required to support this load of 10 kilonewton? So you have to calculate the number of plates now, the first thing. So without exceeding the stress, okay, so there is an stress in the material. So any metal having a stress of maximum stress. So that stress in the material should not exceed of 160 Newton per millimeter square. Okay, so you have to calculate how many plates are required for the particular load without exceeding of the 160 Newton per millimeter square. And also find out the central deflection. Okay, if the material property like Young's modulus is given as 2 into 10 power 5 Newton per millimeter square. So this is a question, so you have to understand question first very properly. That is a primary work to understanding. Later we can go for the solution. Okay, so the length for the spring as per the design, where length of the spring will take as L, that is given as 750 millimeter, and the plate wide, it means the W will be taken as the width of the plate. Sometimes W or will take B, because W generally denotes the load. Okay, so we'll take B as width of the plate, that is given as 70 millimeter, and the thickness of the plate small t given as 8 millimeter. So you need to find the what is that number of plates, that is small n generally will denote as the number of plates. Okay, so number of plates you have to calculate. So now what is the formula for the central deflection? First, what is the formula for a laminated spring or leaf spring to calculate the deflection? So that is where delta is equal to sigma b L square by 4 E T. This is the equation. Okay, so this you have to calculate for the central deflection. So before that, you need to calculate the number of plates are required. Okay, so number of plates required for to support the loads, that you have to calculate first. Later we'll go for this. Okay, so always you have to first write the formula, so that what unknown value you need to calculate, that we will identify first. Okay, so now you have to calculate the number of terms. It means there is an bending stress. Okay, formula for the bending stress for the laminated spring or the leaf spring is, because you have to calculate sigma b first. So sigma b is equal to, there is a formula to calculate that, W L 2 N B T square. So this is the equation, it will be used to calculate the bending stress for a leaf spring. Okay, only for the leaf spring this equation will be used, remember. Okay, so here sigma, which will be given as the maximum bending stress, so that is in the given equation, sigma is given. Okay, and W is the load which you have applied, maximum load, where L is the total length of the uh, spring, and N is the number of turns, number of plates, B is the width, T is the thickness. So the unknown is the number of plate here. So we can modify this equation where N is equal to, it is again 3WL divided by 2 sigma B B T square. That's it. Just if you how to modify this equation. Now calculate what is the number of terms from this equation, where N is equal to 3 into W. W is the load that is given as 10 into 10 power of 3. It means it's an 10,000. Again into length is given 750 by 2 into sigma B is 160 into 2 into 160 into B value is the width, that is 70, and T square, that is 2 square, it means 4, sorry 8 square, so 8 square means 64. So we got 15.69, 15.69. So where number of terms, you have to take the rounded value, so we'll go for 16. Okay, so 16 plates are required to support the load. Hope that's clear to you. Okay, you have to just remember the formula for the bending stress, so that you can calculate the number of plates. So once you got sigma B, then we'll go for the equation for the deflection. Okay, so deflection, where sigma B is 160 into L square is 750 square by 4 into Young's modulus value is given 2 into 10 power of 5 into T is 8, right? This you have to make now, so that you will get the deflection in millimeter. So it's 160 into 750 square by 4 into 2 into 10 power of 5 into 8. So it's 14.06, 14.06 millimeter. Answer is 14.06 millimeter is the central deflection. Central means here the deflection, central deflection for the given parameters. Okay, so in this way you can find the solution, or you can design as per the requirement. Thank you.